Right. Hello, everyone. It's 1 o'clock. Good afternoon. You all had a good weekend. Okay, so last class we were talking about solving equations, right? Let me get back to our calendar here. So we started the solving equations section. I wanted you to try and finish up the homework here for R8 or all the section R's. I had moved those deadlines for you. And 1.4, I believe, is due on Wednesday by 1 p.m. So let's see how much of 1.4. I think we're going to finish it and start 3.1. Let's just see how it goes. Are there any questions right now? Accessing the online stuff, any issues? I have not heard anything about us going on campus. The last thing that I was told is that we would resume next week, but next Monday is actually a holiday. So if we did, is it next week? Yeah, so notice here that Monday, September 6th is a holiday. So if we do go back, we actually wouldn't go back till the 8th. So I haven't heard anything saying that we are not at this point. I would hope that by Wednesday we would know if they're going to change anything, but I will let you know if I hear something. Okay. If we do go back, I think there will be some issues as far as, you know, time, like class starts at 1, you may have to be there earlier just to be able to get in. You know, they only have certain doors of buildings open, and I think there's checkpoints and stuff. So let me find out whatever I can find out this week about that, but I would plan on giving yourself some time. Let's cross that bridge on Wednesday, okay? All right, so here we go. Last time we finished up, we were doing this example 3 where we were solving a radical equation. The main idea behind a radical equation is that you want to isolate the radical and then raise both sides of the equation by whatever power it takes to get rid of the radical, and then you just have to solve the remaining equation. I gave you a set of steps on how to do that. Let's pick up with the next problem out of this session that I want to go through, and it's this one right here. We want to solve an solving an equation quadratic in form. All right, so we should all know going into this what a quadratic equation is. So a quadratic equation is any equation that looks like this: some number in front of x squared plus some other number in front of x plus some other number equals 0. That's a general quadratic equation. Like if I gave you a specific example, something like 2x squared minus 5x, let's say minus 7 equals 0. That would be an example of a quadratic equation. And when it comes to solving quadratic equations, we have 2 different main methods on how to do it. The first method, and the one that I usually recommend you try first, is factoring, which we have talked about already. Like, how do you factor something like that? That's where we made that little x and tried to find the 2 numbers that add, multiply to be something and add. There's that method. But if that method fails, we have what's called the quadratic formula. I know most of you are familiar with this formula. The quadratic formula says that you can always find the solutions to a quadratic equation using this x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So quick poll here. Okay, choice number 1 is yes, choice number 2 is no. Have you seen the quadratic formula proven? Like, have you ever had an instructor show you where this formula comes from? Not just give it to you, but to actually show you where it comes from. Yes or no? Okay, so only one person has said yes. 2 people have said yes now. Okay, and 10 no's. So that means the majority of you have not seen it. seen where it came from. And oops, I accidentally relaunched it. Okay, so depending on time, I may show that to you because this is a STEM math class, and it'd be nice to know where that formula actually came from, right? That it didn't just like appear out of nowhere, like all the formulas we ever use, like human beings had to come up with. And it's not too bad to actually show where it comes from. It's kind of cool. So maybe at the end if I have time. Okay, so that's our two methods to solve a quadratic equation. So what we're doing here is we're not solving a quadratic equation. We're solving an equation that is what we call quadratic in form. And what we mean by that is when we look at it, it doesn't exactly look like a quadratic, but you could almost kind of like squint your eyes just enough and you kind of see it kind of looks like a quadratic. So let's just look at this one. Let me grab it here. And let's notice that it definitely doesn't look exactly like this first form right here, right? It's not some number in front of x squared, right? Because we don't have x squared, we have x plus 2 squared. And then we don't have a number just in front of x, we've got a number in front of x plus 2. We do have a number by itself, minus 12, and then equals 0. So it has similarities, but then there's things that are different. So this is where what we do is we kind of, like I said, squint our eyes and notice that these two are the same, x plus 2 and x plus 2 are the same. And so if those are the same, we can make a substitution, all right? So we're going to come in here and we're going to substitute. I'm going to let, now I get to use any letter I want to use, okay? I'm going to use u. I'm going to let u be x plus 2. And that's because both of these have x plus 2 here. So now what I'm going to do is I'm going to rewrite the equation. Everywhere I see x plus 2, I'm going to replace it with u. So if I do that, this becomes u, this becomes u. It turns into, well, I don't know. Let you tell me here. So, how about Christopher Mora? Christopher, are you here? Cecilia? Oh, wait, Christopher is here?
Yes, sir.
Oh, okay, hey, I missed you last time. I want to make sure I call on you. All right, Christopher, so what would this new equation become in terms of u now instead of the x's?
Be ux squared minus 5u.
What, hold on, what are you looking at? I'm looking at this equation right here. Replacing all the x plus 2's with u's.
U squared plus 4.
I think you're trying too hard. Look, this is u, right? That whole thing in yellow is u. So this becomes u squared, right?
Oh.
Plus 11, and then this whole thing is replaced with u, so that should just be 11u.
Yeah, sorry, I did.
Okay.
I thought you were just replacing x with u, not the whole thing.
No, the whole thing, yeah, so it's the whole expression, x plus 2 is being replaced with u.
I got you.
And so if we do this, Christopher, do you see that right now that looks like a quadratic equation because it's like a number, right? It's a number in front of a variable squared plus another number in front of that variable minus some constant equals 0. So it looks a lot like this now. Do you see that?
Yes, sir.
Okay, does everyone see that? So at this point, we can do the same thing. Thank you, Christopher. We can do the same thing. We can either factor it or we can use a quadratic formula. So if I'm going to factor it, I usually try and factor first. So I'm going to make a little box over here. And I'm going to say, okay, I take the number in front of u squared, multiply it times negative 12 to get negative 12. And then the number in the middle is 11. I try and come up with two numbers that multiply to be negative 12 and add to be 11. So 12 and negative 1 work. And then I go through and I go ahead and factor it. So I'm not going to go through the steps to do this because we've already kind of talked about that. I'm just going to write down what the factored form would be. So this will become u plus 12 times u minus 1. So please understand these dots mean I'm leaving that work to you. Is that all right with everyone? just for the sake of time and getting through these problems, we can't show every single little step or else we'll never see enough problems. Okay, so once we're here, once we're at this point, because we have multiplication between these two things, we set each of the factors equal to 0. So I'm now going to create two new equations. U plus 12 must be 0. The other one is u minus 1 has to be 0. And those are pretty easy to solve for you. You can just subtract 12 on both sides there. You get u is negative 12. And over here, if you add 1 to both sides, you get u is 1. Okay. This is not our answer because the original problem, right? The original problem had x in it, right? So it's saying, hey, solve this for x. Tell me what x needs to be in order to make this true. And our final answer, well, our answer right now is u equals negative 12. So I'm asking you about x and you're telling me about u. It doesn't, we need to go back, okay? We need to switch it. So now at this point, we will replace u, right? We're going to replace those u's with what we said u was earlier in the problem, which was x plus 2. So I replace this u with x plus 2. Replace this u with x plus 2. And we continue. And now solve for x. So subtract 2 here, subtract 2. We get x is negative 14. And then over here, x equals, subtract 2, subtract 2. You get x is negative 1. So we have two solutions. Are there any questions on that? So do we need to check our answers? Oh, let me say it this way. We should always check our answers, all right, just to be like safe. But do we have to check our answers here? Do you remember from last class what I told you about checking the answers?
No, because we didn't do any algebra with the square root.
Yeah, there was a very special, let me see if I can find it in my notes. Where is it? Hello. I know I gave you all the steps. Oh, I know it's here. Maybe I did it later. Where is it? Okay, this is what I did. I gave you the steps and I worked the problem as we did it. So I said, you know, if you're trying to find solve a radical equation, you isolate the radical, you raise both sides of the equation to a power. I said, if that power was even, you have to check your answers, right? Well, in this problem, first of all, we're not doing a radical equation, right? This is a quadratic form problem. So we never raised both sides to an even number. We never did that. And because of that, you don't have to check your answers. Now, it wouldn't be bad to check just to make sure you got it right, but you don't have to. To check it though, you'd plug either one of these values of x, you plug it in here and just make sure it turns out to be 0. Okay, any questions on that quadratic form problem?
When did you say it's necessary to check it?
If you ever raise both sides of an equation to an even power. So if you square both sides, if you raise both sides to the 4th power or 6th power, then you always have to check your answers because some of them may not work.
Okay.
Okay, here's another one. So one of the things I'll warn you about now is that when you take a test, I'm just going to say, like, I'm not going to give you this, okay? I'm not going to give you that. All I'm going to give you is, you know, find the solutions of this equation. So there's going to be nothing that indicates to you what type of equation it is. So part of this, what you'll be tested on is kind of a recognition, a problem recognition. You have to be able to look at that and realize, oh, hey, this is a quadratic form problem. And again, the only way to see that is to, again, you have to kind of squint your eyes and realize you have an x squared minus 1 and x squared minus 1 there, right? Those are identical. And so let's make a substitution. You don't want to use gray. Let's make our substitution. Let's let u be, okay, let's see here. Cecilia, are you here?
Yes.
Okay, what's u going to be here?
X squared minus 1.
Okay, x squared minus 1, good. And then can you tell me what the new equation is rewritten, replacing the x squared minus 1s with u?
U squared plus U minus 12 equals 0.
Okay, good. Now, I don't want to put you on the spot, Cecilia, but how are you with your factoring? Do you feel like you could factor that?
I could. I just need a second.
Okay, yeah, take your time. Let's see if Cecilia can get it. And I told y'all before, like everybody's at a different spot here in this class. So some of you are going to have to make that little table and then do that factoring by grouping that I showed you a few classes ago. And some of you are just going to be able to look at that and tell me what it is. It just depends on you. On you, yeah, not this you. Any luck?
Would it be X plus 4 and X minus 3?
Yes and no. What did you say again?
X plus 4 and X minus 3.
Okay, so what do y'all think about that?
Sounds correct. It has to be a U.
Yeah, u plus 4, u minus 3. This is very important because this is a common mistake. Students will forget, oh, wait, the variable's u, not x. And then you forget to switch back. So the factoring is correct, Cecilia. It's plus 4 and minus 3, but it's got to be the variable u plus 4, u minus 3. You may have meant that, okay, but I'm glad you said that because it gave me a chance to emphasize that. Is that good, Cecilia?
Yeah, I got
Okay.
it. Thank you.
Good. Okay, now once we're here, we just set each of these equal to 0. Does anyone know why we always set these equal to 0? I kind of just glossed. I never even really talked about why it is that you can set each of those things to 0.
Because if you set them to 0, when you multiply them by the other equation, the answer will always be 0.
Okay, yeah, so I think what Josiah is saying is that, look, do you all agree that if that turned out to be 0, that it wouldn't matter what this is anymore? The x minus 3 wouldn't matter because 0 times anything will give you 0 and then it would work. And then the other way is you can say, okay, well, forget that one. You know, if this one is 0, then it doesn't matter what the one on the left is because when you multiply them, it'll be 0. This is called the zero factor property, all right? And it seems like duh, but it can be misused. Watch, let me show you something. So what this property says is this. Let's say I have something A, and I multiply it times B, and I get 0, okay? So if two things multiply to be 0, then here's what I can tell you. A has to be 0 or B has to be 0. So the only way to multiply two things together and get 0 is if one of them is 0. So this is the thing I think most people like say, yeah, duh, yes, I get it. But here's where it gets misused. People will think that they can use that for any number. Like if I tell you if A times B equals 5, then people will say, oh, then that means that A equals 5 or B equals 5. So if I tell you two numbers multiply to be 5, does that mean that they both have to be 5? Or one of them has to be 5? You understand what I'm saying? Like if two numbers multiply to be 0, then I guarantee you one of them has to be 0. But if two numbers multiply to be something other than 0, like 5, does that mean that one of them has to be 5? Can somebody give me an example of two numbers that multiply to be 5, but neither one of them is 5?
2.5 and 2.
What did you say?
2.5 and 2.
2.5, oh, 2.5. 2.5 times 2. That does equal 5. Do y'all agree? 2.5 times 2 is 5. So look, this is an example where two numbers multiply to be 5 and neither one of them are 5. So it's not guaranteed, and that's why you cannot do this. So like if you ever came across let's just say you came across a quadratic like this. I know I'm going off topic here, but let's say you had a quadratic that looked like this. Not equal to 0, but equal to 5. If you factor the left-hand side, just like we did before in the previous problem, and you have equal to 5, you cannot set each of these factors to 5. That is invalid and that is incorrect. Okay, does anyone know how you would solve this though? If you couldn't do this, how would you solve this then?
You move the 5 to the other side by subtracting it.
That's right, you have to move the 5 over first. And the reason why you have to is because we want to use the zero factor property, and that means you have to have one side of the equation equal to 0, not 5. So I'm sure you remember in algebra, they told you, oh, move everything over to one side to get equal to 0. Well, that's the whole reason why, is so we can exploit that property. Okay, I went off on a little tangent there. Let's get back to this. Okay, so here we are. I'm going to solve each of these for you. And then let's see, Adam, can you tell me the next step? Or are we done? Adam? Is Adam here?
I'm here.
Okay, there you are. So Adam,
Could you restate the question, please?
yes, I just want to know where to go from here. We've
I believe
solved,
that-
we have u equals 2 numbers, right? So are we done?
No, we have to, I'm sorry, check the answers.
Well, the original problem, Adam, had x's in it, right?
Mhm.
So we're trying to solve for x, and your answers are u equals this and u equals that. So that's kind of like me asking you, Adam, like, what's your favorite color, right? And then you tell me 44. You know, it's like,
Okay,
these aren't even the same things yet right now. Right now, our answers in terms of u, we need our answers in terms of x, the original variable. So you
Mhm.
got to get this back. So what am I going to do now? What was u? What was the substitution we made?
x squared minus 1.
Yeah, so we're going to replace that u with x squared minus 1. So I replace this with x squared minus 1 equals -4, and then the other equation becomes x squared minus 1 equals 3. We good, Adam?
Yes.
Okay, now, next step. We have to solve each of these for x, right? So let me get the x squareds by themselves. I'm going to add 1 here, add 1 here. So you get x squared equals -3. And then over here, I add 1 and add 1. And I get x squared equals 4. Okay, Gregory? You there?
Yes.
Okay, Gregory. What can you tell me about that first equation?
It won't square.
It won't have a solution,
Yes,
right? Okay, why, Gregory?
because you can't have a negative.
That's right. When we square a number, right, anything squared can never be negative. Unless we're talking about imaginary numbers, okay? And we are not going to talk about imaginary numbers right now, all right? So for right now, we are going, in the instructions, do you see that it says, oh, it's not working. Hold on. There we go. In the instructions, it says, find the real solutions. The real solutions means you're not allowed to be looking at imaginary numbers. So Gregory is saying no number squared will ever be negative. So there's no real solution here. All right. There's no real solution for that equation. What about the other one, Gregory? Do you want to talk about that one?
What did it just be 2?
Okay. So how did you do that? Were you just like mentally doing it, or did you actually do some algebra to do it?
2 times 2 is 4.
Okay, yeah, 2 times 2 is 4. Yeah. Is that the only answer though?
Yes.
Is there another number that you could multiply it times itself and get +4 still?
-2.
1.
-2 and -2, right? So the proper way to go about this at this step would be to take the square root on both sides And do you remember us talking about this last class? Because we initiated the square root, right? Because we did it. I have to have a plus or minus. And so this gives me x on the left side and on the right plus or minus 2. So we have a grand total of 2 answers to this problem. Positive and negative 2 are the 2 solutions.
If the 3 were not negative, would it be the square root of 3?
It would be plus or minus the square root of 3. Yep.
Okay.
Yeah. So Lizana's asking if that negative would have not been negative, then we would have done the same thing. Square root on both sides, plus or minus, and then we just would have had plus or minus root 3, 2 answers. We would have a total of 4 answers. Here we only have 2 though. Okay. Any questions? All right, here we go. Next one. Another quadratic form. So if you look back at the 2 problems I've done so far, we've had a problem where I've told you kind of squint your eyes and you'll see that you can replace u with something, right? Or let u be something. This problem is less obvious. Not only that, you could almost argue that this is a radical equation because it has a radical in it, doesn't it? So you could be thinking about this by doing it the way we did last class, where you isolate the radical, square both sides, which, by the way, that will work for this. But I want you to see it I want you to try and see this as a quadratic form. I want to see if anyone in here, well, I'll call on someone. Well, I'll take a volunteer. Can anybody see that this is quadratic form and tell me what the u is?
The square root of x.
You want u to be the square root of x? Josiah, yes?
Yes.
Okay, so I agree with you in this sense. This would then become 2u. Yeah, I agree with that. That would become 2u, and this would be minus 3 equals 0. But Josiah, what is the x going to become?
U squared.
Okay, so why? Why is that going to be?
If you
Go ahead.
square the square root of x, it's equal to x.
Yes, so Josiah is seeing that that x is actually the square root of x squared. Everybody has to see that. So it's not like the previous problem where it was obvious, x squared minus 1, x squared minus 1. Oh, that'll be the u. It's not as obvious in this problem. You have to realize that x is the square root of x squared. And if you do it that way and do the substitution that Josiah said of square root of x, then this indeed will become u squared. And then plus 2u. 2u minus 3 equals 0. Anybody have a question on that?
So could we have said it? Okay, this could be going a little bit longer. Could we have just squared that entire side and then just set x to u or u to x?
Square the entire side.
So square x, square 2 square root of x, and square negative 3.
Ah, okay, good question. So the question is being asked, could we have taken this, squared the left side and squared the right side? So algebraically, yes, you could do that. Okay, you're always allowed to square both sides of an equation. That's correct. I mean, that would be a legal move. The question would be whether or not you square it properly. So squaring the left-hand side, you do not square each of the terms. That would be illegal. You can only square each of these if there's multiplication between them. So to square this, you would actually have to FOIL it. You would have to do this times itself, which I assure you is going to be very ugly because you're going to have to do a total of 9 multiplications. 1, 2, 3, 4, 5, 6, 7, 8, 9 multiplications. It's going to be extremely ugly. And trust me, you don't want to go down that path. So it's kind of a yes and no answer. Yes, you can square both sides, but no, it's not going to square each one individually. So I would avoid it. Does that make sense?
Yes.
Okay. All right, so we're over here. This factors, I'm gonna go a little faster here. This should factor to be u, let's see, minus no, u plus 3, u minus 1 is the way that factors. Again, not showing this work, trusting you could get that on your own. And then that gives us two equations, u plus 3 equals 0 and u minus 1 equals 0. I subtract 3 on both sides and I add 1 on both sides. And now we replace u with what? Remember, what was that substitution we made?
Square
Root
Square
root
root
of
of x.
Okay, so this becomes root x equals -3 and root x equals 1. Okay, doing good. Let's see, Josiah, got Josiah, Gloria. Gloria. I don't see Gloria. Juan? No, Juan.
Yes.
Oh, wait, there you are. Oh, there you are, Juan. How's it going? Okay, so I'm glad, Juan, that you have your camera on. Everyone who has a camera on, it really helps. Juan, I can tell you, you get this. I can just tell by the look on your face. You've done this, you're comfortable with this. So that's good. So thank you for continuing to pay attention, because you never know. There might be something I say that you just never saw it that way, or so hang in there. Hopefully we'll get to some stuff that that pushes you a little bit more. All right, so but now you're on the spot, because I'd like to know what to do now.
Just to square both sides to cancel the square root.
Yep, square both sides. Okay, so Juan is saying that we have square roots, like radical equations. So he's going to square both sides here. Same thing over here. Oh. Okay, what do you get on the left-hand side, Juan?
9.
X is 9. And then on the right?
1.
Okay. Is that it?
And then don't you have to check answers?
Absolutely, because we square both sides. At any point in the problem, if you ever square both sides, you've got to check your answers. So we have to check them. Oh, well, okay, let's do it. I'm gonna just copy this. I'm gonna show you the proper way to check these. Here's the original equation. You have to go back to the original equation. Okay, you can't go back to any other step in the work. You have to go to the original. And let me check now. Let me check the first solution we had. X is 9. Okay, so I'm going to replace all the x's with 9 in the equation. 9 plus 2 square root of 9 minus 3. And it becomes a question, is that 0? That's 9 plus 2 times 3 minus 3. And that's going to be 9 plus 6 minus 3. Whoa, wait a minute, hold on. That's 15 minus 3. That's not 0. That's not 0, is it? Which means 9 is not a solution. Hey, don't forget, everyone, remember this step right here, square root of 9 is 3. Remember that I talked about that last class. It's not plus or minus 3, because we did not take the square root on both sides of an equation, right? So anytime it's just the square root of a number, it's always the positive answer, that's what we call the principal root. So the square root of 9, or the principal root of 9, is 3. Okay, that didn't work. Maybe the other one will. Question 1.
Yes.
Do one of these have to work? Have to work. What do you think?
It doesn't.
Do you think we have to have a solution?
No.
No? Yeah, we don't have to. We can have no solutions, okay? So you can't just like check one and say, oh, it didn't work, so that means the other one has to. No, you could have no solutions at all. They could both work. One of them could work. None of them could work. We have to check it, unfortunately. So here we go. 1, we're replacing x with 1. 1 plus 2 square root of 1 minus 3 equals 0. It's a question, right? So 1 plus, okay, the square root of 1 is 1. So 2 times 1 is 2. And that checks. So that's 3 minus 3. We have one answer, x is 1. So I might be getting a little bit ahead of myself, but you might recall this from previous classes. if you have a function, which we're going to talk about in the next section, if you have a function that you graph, okay, f of x, then anywhere that the graph hits the x-axis, right there, that's called an x-intercept of the graph. The way you can find the x-intercepts of a graph is to set the function equal to 0. That's how we do it. Okay, now again, we'll talk about this more in a little while. So if you look at this equation up here, I can act like the left side of this is a function. And I'm asking myself, where is that function equal to 0? Right, that's what I'm asking. So what I'm going to do is I'm going to go to my graphing thing here, Desmos, this online graphing utility, and I'm going to type this in as a function. You know what? Hold on. I don't want that. There we go. So it was x plus 2 square root. Oh, square root of x minus 3. So there is the graph of that function. Okay. And I want you to pay close attention to where it crosses the x-axis. Do you all see where it crosses? Right here at 1, right? So the x-intercept of this function is x equals 1. And that corresponds to what we just did. If we looked at this as a function, if we set it to 0, we're asking where it crosses the x-axis, and we just found that that solution would be at 1. Do you see how 9 doesn't make sense? 9, if I go out to 9, the graph definitely does not cross here, right? It does not cross. All right. All right, so that was a weird one. Let's see. Let's take a look at this one. This is a good one. Let me give you a few minutes to see if you can do this one. I haven't done one like this, but I just kind of want to see what people do. All right, so we'll take 2-3 minutes, see how far you can go. You don't have to do this the same way we've done anything. Just see, I want to see what you know about how to solve that on your own right now. Maybe 30 more seconds. Okay. I'm going to take a volunteer and I'm going to hope, well, I'm going to hope you did it right, but I'm also kind of hoping you did it wrong because I want to be able to make a point. But let's see what happens. Anyone want to volunteer? How they got this?
Is it -4?
-4. Okay. So can you tell me how you did that? Whoa, what's going on here? Hold on a second. Whoa.
Or actually, I think, sorry, it's -2.
All right. Just tell me how you went about it. And that way I can see how you approached it.
First off, I took the square root of each side of the equation.
Okay. So you took the square root of the left side. And when you did that, did you do plus or minus or no?
Oh, I forgot to do that.
Okay, but you would have to, right? Plus or minus?
Yes, plus or minus.
Okay. And then you took the square root of the right side. Okay, that is a legal move. Okay, that's a legal move, what just happened. Okay, so what do you get on the left side?
Left side, you get x equals plus or minus x equals the x squared on the left side.
X squared on the left side?
Yes,
Okay, good. The square root of x to the fourth is x squared, and then plus or minus, then what do you get here?
that would be 2x.
2x, okay? I agree with that.
And then plus or minus, and then you use algebra to either subtract or add 2x to both sides of the equation to get
Okay,
x.
so you have two, you're saying that you have two different equations that you're gonna set up from this?
Yes,
Okay, the first equation is gonna be,
x squared plus 2x.
I'll do it this way, x squared equals 2x and x squared equals negative 2x.
Yeah,
Everyone see what we're doing? Taking the two different scenarios here? Okay, now, this is all good so far. What next?
then for the equation, for both equations, you you use algebra for, on the right side, you subtract 2x from each side of the equation, and on the left, or got that backwards. On the left side, you subtract 2x from each side of
So
the
you
equation.
subtracted, so you moved everything over to one side right now?
Yes,
So you moved the 2x over with the x squared like that, made it equal 0?
Yes.
Okay, and then on the other equation, you did the same thing, but you added 2x on both sides?
yes.
Okay,
And then
this is all good so far.
from there, you factor out x.
Okay,
from-
so on this first one, on the left, you said a GCF, greatest common factor, you pull out an x,
Yes,
and you get that. And you can also pull out an x on the other one and get this.
and then using the zero factor property, you can solve for,
Yep. There's a multiplication between those, right? So you
Yeah.
can set the first one to 0. And you can set the second one to 0. And you do the same thing over here. Set the first one to 0. Set the second one to 0. Good. This is good. On this one, that's just x is 0. You have the answer. Boom, you're done. The other one, you add 2 to both sides. So x is 2. Over here, you have x equals 0. I don't need to really worry about it because I already have x equals 0. On this one, you subtract 2 on both sides, and you get x is negative 2. Perfect. That works. So do you see how, does everyone see how important it is to do the plus or minus here? If you don't do that plus or minus, you would have lost at least one solution that way. All right. Any questions on the way Josiah went about this? Did anybody do it different? Want to share?
Yes,
Okay, how did you do it?
I just moved the 4x squared to the other side, so it would be x to the power of 4 minus 4x squared equals 0.
Okay, everybody, that's a legal move in the very beginning. Just move that to the left, make it minus, right? Go ahead, Juan.
Take out a x squared from the equation, right?
Okay, so factoring, right? Greatest common factor, GCF.
And then
Good.
just x squared equals 0.
So
And
you
x
set the
squared-
first one to 0. And you set the other one to 0? Sorry.
Yeah.
Right. Okay,
and
I'm just curious, how did you do this from here?
x equals 0 and x equals plus minus 2.
Yeah, so on this first one, x equals 0, that's because the only number you can square to get 0 is 0 itself, right? Only 0 squared gives you 0. And then here, I mean, Juan, did you just look at this or did you actually do something algebraically?
Well, I just set it equal to x squared equals 4.
Okay, so you move the 4 to the other side. And then you did square root plus or minus, right?
Yes.
And that gives you the other two solutions, plus or minus 2. Those are the same 3 solutions that Josiah got, right? 0, positive, and negative 2. Good, that'll work also. Here's something else you could have done here at this step. If you wanted to, you could have looked at that as a difference of squares. Because isn't x squared minus 4 x plus 2 times x minus 2? And then you could have set each of those factors to 0. And you would have got the same two answers, negative and positive 2. So we talked about this, a few classes ago, that, we're trying to get from point A to point B, and that there's different paths. And as long as you don't break rules, you can get there. You just have to get comfortable. I don't want you to think of math at this level. I don't want you to be thinking of math as like there's always one way to do something. It's more like, if I tell you to draw, I give you a blank canvas and tell you to paint something, I want you to paint a picture of a cow. Like at the end, hopefully everyone's picture looks like a cow, but everyone's going to have different ways that they arrived at that cow. It's kind of the same thing here. The tools of algebra are like the paint and the brushes. You kind of get to use them as long as you don't like throw your paint away, right? If you throw the paint away, you can't paint the picture. So anyway, okay, so that's good. Let me show you the incorrect way to do this, which is very dangerous, and I see it happen a lot even in my calculus classes. All right, x to the 4th equals 4x squared. So here's the step that students will make that is wrong. The first thing they do is they divide both sides by x squared. Now that may seem like it's an okay algebra move. Like it may seem like it's okay. Let's see what happens. On the right side, the x squareds cancel and you get 4, right? And on the left side, x to the 4th over x squared, you subtract, right? 4 minus 2, that gives you x squared. Okay, well, that's something we can do something with, right? Do square root on both sides. And you get x equals plus or minus 2. What's wrong with this?
We're missing the 0.
We're missing that 0, right? Wasn't 0 a solution? So why do you think you're missing 0? What was our very first step? Division by x squared, right? Anytime you divide by something, you have to promise me it's not 0, right? So when we did this step of dividing by x squared, there's a little asterisk there, and we're saying to ourselves, promise x isn't 0, right? Or else I can't do that move algebraically. So by doing that step, we eliminate 0 as ever being a possible candidate for an answer, but we have lost the answer. So the rule of thumb, or kind of like the moral of the story, is that at all costs, try to avoid ever dividing both sides of an equation by a variable. By a variable. You can always divide both sides of an equation by a number, like 4 or 2 or 5. You just can't divide by 0, and you can't divide, well, when you divide by a variable, you need to start looking at the possibility that you may have lost an answer. So the proper technique is to try and do either what Josiah or Juan did. Josiah did the square root thing. Juan did the move everything over to one side. If I had to choose my favorite way, or like my way that I think is safe, move everything to one side. That's what because then, I don't know. I mean, you still have to remember the plus or minus later, but I think it's just safer. Okay. We're almost done here. One more problem. So this problem is just to make sure you remember how to factor something when you have more than 3 terms. So it doesn't look like a quadratic anymore. We have 1, 2, 3, 4 terms. And whenever you have 4 terms, does anybody remember how to try to factor when you have 4 terms? There's a method. You know what it's called?
Is it factoring by grouping?
By grouping, exactly. Factoring by grouping, good. So the way that factoring by grouping works is this. And again, this goes back to how you were taught, depends, okay? But again, the key is that we have 4 terms. That's the thing that should be like kind of tipping you off that we need to do something doing grouping. grouping does not always work. It does not always work. It has, certain things have to happen a certain way. So I teach my students this. To do grouping, you have your four terms. Your four terms are x cubed minus x squared minus 4x plus 4. There they are. I always say, go to your first two terms right after the second term, draw a slash mark. We did this before, didn't we? When we were doing that cross thing, I wound up giving you a problem. The problem turned into something like this. We're going to factor a GCF out of just the first two. So just the first two both have x squared in them. We'll be left with x minus 1. And then over here, I need to see if I can pull a GCF out of both of those. So I'm going to pull a -4 out, and that will leave me with x minus 1 there. So I pulled -4 out of each of those terms, and it turned this into -4 times x minus 1. Now for grouping to work, okay, the only way grouping ever works is if these two things match, which they do. So because they do, and I know we talked about this before, I'm going to write down the thing that matches. And then next to it, I write the two things that were out in front. So x squared minus 4, and then equals 0. I could use the zero factor property right now because I have multiplication right here, but I'm going to go one step further. And I'm going to recognize the x squared minus 4 is a difference of squares, right? That's a difference of squares, goes here. And now the zero factor property says I have three things being multiplied together. I can set each 3 equal to 0. So I have 3 equations. You should get 3 answers. 1, -2, and 2. All right. Any questions on this? I want to just verify that I got all the problems that I wanted to get. There should have been 8 examples, I think. 8, yeah, 8 examples. All right, so there we go. We are done with the solving equations section. All right. And we're ready to move into functions, domains, and difference quotient. Y'all doing all right? Let's see here. Move this up. All right. Functions, domains, and difference quotients. So in this section, we need to first make sure we all understand what a function is. We need to understand what its domain is. And then we have this idea of a difference quotient, which is a completely separate idea. All right. So first, let's talk about functions. I think I may type this out. It might be a little bit easier. I'm going to give you a definition. A function is a rule which assigns to each element, x in its domain exactly one element f of x, f of x in its range. Okay, so that is like the more formal definition of a function. But when it comes to functions, I think they're most easily demonstrated with pictures, right? So the idea of a function is this. You have a machine, right? I'm sure you've seen this picture before. You have a machine that basically takes things in and spits things out. So you have input and output. I always like to think of a function when I'm first introducing it. I always think of like a car wash, right? So like, you know, you take your car to a car wash and you go in on one end and isn't that always fun when you're in a car wash? There's just something about it. I don't know what the feeling where you just kind of sit back and just go through, you know, something peaceful about it, right? So, you know, you start at one end, the input's the car, right? The input is the dirty car and the output's the clean car, right? So a function is the same thing, except that the input for a function is going to be a number, right? So we have numbers that go in. Something happens to those numbers that depends on the function. And then the output is also numbers. Now, in general, okay, in general, like math, I don't know if any of you are math majors, but later on you might discover, or we will maybe talk a little bit about here, a function does not always have to take a number and spit out a number. You can have a function that takes in a function and spits out another function. So, but most of the time when you're first being introduced to functions, the idea is a number in, a number out. Okay, now the numbers that we plug into a function, all the things that can be plugged in compromise what is called the domain. They make up what is called the domain of the function, the domain of the function f. You might see it abbreviated this way, dom f. Okay, so go back to the car wash, right? Like I can go drive my truck through the car wash, no problem, right? But if you bring an 18-wheeler there, the car wash is not designed for the 18-wheeler, right? It's too small and the 18-wheeler can't go through there. So there are certain restrictions on what that car wash function can handle, right? Just like we know in algebra that there are certain things you can't do algebraically. And so the domain is basically all the values of x, or all the numbers that are valid for a given function. Some functions have no problems with numbers. Some functions you can plug any number in and it's fine. It's like a car wash that'll take any car, no matter what the size or anything else. Or you'll have functions like the square root of x, where you cannot have a negative number going because you can't take square root of a negative number. So the domain is very important. It's the things that are valid, the numbers that are good or not good. All of the x's that can go in, all of the x's make up its domain. Now the output of a function, okay, the output, oh, I did something wrong here. Do y'all see this little f of x? You see that right there? Please erase that. F is the function. F is the function that actually goes from here to here. F of x is something different. So if I take x and I plug it into this function, it spits out a specific value, and that is called f of x. A lot of times students will make a mistake and they will think that, you know, if I write down, like let's say I write down f of x equals x squared. Okay, and I ask them, you know, what is this? They'll say, oh, that's the name of the function. It's called f of x. F of x is not the name of the function. The name of the function is always the letter that's out here. So this is the f function. If I wrote down g of x equals the square root of x, the name of this function is g, right? G of x is the actual value of the function at x. So there's a difference between the name of the function and its value at a certain point. So a function takes something in and spits, very important word in here, exactly one element out. So like in order to be a car wash, you can't put one car in, right? And get two cars out the other end. Like you make that car wash and I want to go into business with you, right? So that basically makes no function behaves that way. So you cannot have one input go to two outputs. Now it is possible to have two inputs go to the same output, but it is not possible to have one input go to two. So I'll give you an illustration of this. I'll give it to you with specific examples. Let's say we take, for example, the function f of x equals x squared. And let me draw a picture. Where would the number 2 go? If I sent it through this function, where does it get sent to? 2 squared, right? It's 4. Go with me? Okay, but look at this. What about -2? Where does that go? -2 squared also goes to 4, right? So is that still a function? Is this one car becoming 2 cars, or is this 2 cars coming out looking almost the same? You know what I'm saying? Do you understand what I'm saying with the car wash thing? Like, it is possible to put 2 cars into a car wash and have them come out looking, you know, almost exactly the same. Like, that makes sense. But it does not make sense to have one car go to 2 things. So this is a function. Even though these 2 go to the same place, that does not, what's the word I'm looking for? That does not change the fact that it's a function. So this does work. What you cannot have is this. Okay, if I told you that you had 2 goes in and it spits out 4, and it also spits out -4, this would fail to be a function. Okay, we're not going to get too much more into that. All I'm interested in now is I'm going to give you some functions, and we want to make sure we know how to evaluate them. Okay, so let's just see. Let me give you an example. So we want to evaluate the function f of x equals, let me see, I have one ready to go here. So here's a function. And I want to evaluate this at a couple of places. The first thing I want to do is I want to know what f of 0 is. Then I want to know what f of 2 is. Then I want to know what f of -2 is. Then I want to know what f of -x is. Then I want to know what f of, or no, negative f of x is. There's more. And I want to know what f of x plus 1 is. Then I want to know what f of 3x is. Last one. I want to know what f of x plus h is. Okay, so it's like we're given a car wash, right? We're given a car wash, and we're asked to send all these different cars through the car wash to see what comes out the other side, all right? So we start with the first one, f of 0. All right, so just in regular, like just street talk, like you're talking to your friend, Lorena, are you there? Lorena. I don't see Lorena. Megan? Tavi? Hey, Tavi, I said that right, yes? No?
Yeah, you did.
You did.
Wait, what was the question, sir? F of 0?
Yeah, so I just want you to kind of explain in just basic like English words, like when I ask you to find f of 0, what are you actually going to do?
Oh, plug the 0 into all of the x values?
Yes, exactly, right? Just plug in 0 for every x you see, replace it with 0. Now that may seem obvious right now, but it's going to become important in a minute. So replace them all with zeros. So I'm going to go 3, I replace the x with 0, I square it, then I say 2 times, I replace the x with 0, and then I subtract 2. And then you do your order of operations, and you go through all this. Everyone here should get -2. And that shouldn't be too difficult for everyone to understand, right? Am I pushing too far? Can I assume everyone can just say this is 0 plus 0 minus 2? No. Okay, Tavi, let's keep going. So what does f of 2 mean?
F of 2 means we plug 2 into all of the x values the same way.
Same way. Okay, so now, of course, not going to be quite as easy because we have to actually compute these. They're not just going to disappear because the zeros make things disappear. So order of operations, Tavi, this will be the last thing I ask you. Can you kind of help me work here? What do I do here first?
I would distribute the exponent to the 2 first.
Okay.
And
so you square that, get 4.
yeah. And then I would do 3 times 4, which is 12, and then multiply the 2 times 2, which is 4, and
Mhm.
then finally subtract the 2.
There you go. Okay, 16, this should give us 14. Okay. Everything's good, everyone happy? Nothing crazy here? All right, Carissa, you're up. So tell me first in words what you're gonna do here.
I would plug the -2 in as the x.
Okay, so this one's a little different, so I want you to carefully tell me what to write here. Just plug it
Okay.
in, so go ahead.
So 3 times the -2 would be in parentheses.
-2 in parentheses, very good, very important point right there. Okay,
And then plus 2 times the -2 in parentheses,
good.
-2.
Okay, good. Now, Carissa, why is it so important that this -2 is in parentheses?
Because if we don't specify where the parentheses are, it could be either a negative number or a positive number.
That's right. So we discussed this a little bit in class last time. -2 squared versus -2 squared. Those are not the same answer. The one on the left is -4. The one on the right is +4. And so when we are saying, and this is going to go on for the rest of your life ever doing algebra, whenever you have something like x squared, see that x squared? Please always think of this as being x squared. This x is always in parentheses. So if you're plugging -2 in, it's got to be the -2 in parentheses squared. Okay, Carissa, you want to keep going?
Sure.
Okay.
So the -2 in parentheses to the second power would equal +4.
Mm-hmm.
So then 3 times 4 is 12.
Good.
Plus 2 times -2 is -4. So it's
Good.
-4. And then -2.
Good.
And then that would give us 6.
6. Good job. Okay. All right. Things are flowing pretty good here. Chris, I was going to give you 2 of them, if that's all right. You feel good about
Okay. Sure.
that? Okay. So now, Carissa, in words, what are we doing?
We would be replacing the x's with a -x.
Yeah, we're replacing the x's with -x's. That's what we're doing, right? Whatever's here in green is what goes in for these x's. Okay, so go ahead and read that out to me then.
So that would be 3 times -x in parentheses to the second power
-x in parentheses squared. Good,
plus 2 times -x in parentheses
good.
-2.
Very good. All right. Now, again, this -x in parentheses squared is very important. Because here, -2 squared, we actually know what -2 times -2 is, right? -2 times -2, that gives you +4. -x squared, we don't know what it is because we don't know the value of x. But would you agree, hopefully you all agree, that if you took -x and squared it, that is the same as x squared? Because this means -x times -x, which a negative times a negative would always give you a positive. So all you're ever going to really be doing is taking the x's and squaring the x values and squaring them. The negative becomes, well, it vanishes, I guess. So that means that this next line should be 3x squared because you squared the -x. Now, Carissa, how about this piece?
That would become -2x.
-2x, and then -2. And there's no numerical answer here, okay? So in the first 3 problems that we did, the number went in, went through the function, and then a number came out, right? In part D, for the first time, right? For the first time, part D, we did a variable went in to the function, and then I had a variable expression come out, right? We plugged in -x, and it spit out not a number, but a variable expression. Very important concept here. Numbers go to numbers, variables go to variables. All right, Lizana, how's it going?
It's okay.
Okay, all right. So look, on this one, Lizana,
Mm.
you see the minus here? Okay, I'm gonna just cover it up. Forget it's there for a minute. What is f of x?
X.
What does that mean? What are you plugging in? What are you plugging into the function?
Is it just X?
Just x, right? Right, which is exactly what this is up here in blue, right? I mean, that is f of x right there. So Lizana, what is putting a negative in front of that gonna do? So what would happen if you put a negative in front of this entire function? Wouldn't it just act like a -1 and just distribute through? Does that make sense, Lizana?
Yeah.
Like this would go here and then here and then here. So you wind up getting -3x squared minus 2x plus 2. So you could say, I mean, Lizana, if you were to try and explain this to somebody, you would say, look, negative f of x just means take the original function and then change all the signs, right? Everything that was positive, make it negative. Everything that was negative, make it positive. Would that be fair, Lizana, to say it that way? Okay.
Yeah.
Good. All right, we need to do these now. I'm gonna move these down here. I'm also gonna bring the function down here. Now, I'm taking my time through this. I hope you feel like I'm going kind of at a decent pace here. Because this is really important. It becomes very hard to do what we're about to do if you can't get this concept down. All right, Hugo, you ready? I don't even see Hugo. Amanda? Oh, Amanda, okay. Michelle,
Yes.
there you are. Okay, Michelle. Can you tell me just in like, again, like just words, what part G is telling us to do?
You're gonna plug in the x plus 1 into the x's.
So replace all the x's in the original function with x plus 1s?
Yes.
Okay, I'm gonna say it again, everyone, just so we're all on the same page. We're gonna replace all the x's with x plus 1s, right? That's what we're about to do. We are not just gonna take the function and add 1 to it, right? That's not what this means. Having plus 1 here does not mean just adding a 1 onto the end of this. It's all the x's get replaced with x plus 1s. So this is not right, okay? So what you said was correct, Michelle. We are going to replace. So go ahead and tell me. I want to know, like, tell me how to write this with all the parentheses and everything.
Parentheses times x plus 1.
So 3 parentheses x plus 1
Close parentheses.
close parentheses square, yeah,
Plus parentheses x plus 1 and then close parentheses.
and a 2 in front of it, right?
Yes.
Okay, I didn't hear it. If you said 2, I didn't hear it. And then finally,
Minus 2.
minus 2. Is it raining? It's raining. Okay. All right, good. Does everyone agree with that? Everyone good? Okay, we are not done. We need to figure out what this is. All right, we have to figure out what this is. We have to simplify it. So when we look at this, the easiest part of the simplification here is multiplying the 2 through. That's easy. The other part that's kind of, well, the part that's a little bit challenging, I think, and you just need to make sure you're paying attention, is you've got to square that, don't you? You've got to actually square that. So that means you have to do this. X plus 1 times x plus 1. Please do not square each of them. Do not square the x squared and the 1. Do not tell me Do not tell me that that's x squared plus 1, because it's not, all right? You have to FOIL it out. So this becomes x squared plus x plus 1. So x squared plus 2x plus 1. So that's my little scratch work. Now I'm ready to come back over here and write this. I have the 3 that's out front here. Oh, hey, could I multiply the 3 through first? Could I have made this 3x plus 3 and then square it?
Yes.
Why not? Why could I have not multiplied the 3 through before squaring?
The square is only going to what's in the parentheses.
It is, I agree that it is, but remember order of operations, Desiree, right?
Yes.
Parentheses first, right? Then exponents. So you have to have done the exponents first before you do the multiplication. Okay, so that is why we can't. So the 3's still here, and then we have that stuff in green, which I just did on the side, is x squared plus 2x plus 1. Then plus 2x plus 2, then minus 2. So distributing through here, 2x plus 2, minus 2. And then this one, I squared that, I followed that out, got this. Now the 3 can go through, okay?
Wouldn't you combine like terms now?
Now like terms, yes. Just can get all the stuff together. So I have 3x squared. Okay, I have 9 x's, I believe, 6 x's and 2 x's. Wait, not 9, 8 x's. So taking care of that, taking care of that, taking care of that. And that should just be plus 3. For part G, a variable expression went in and a variable expression came out. All right. The last 2, make sure you have them copied down. I'm going to put you all in breakout rooms and give you all about 10 minutes to see how far you can get with these 2. Make sure you copy down the function, copy down the 2 things I want. Talk to each other, help each other out. If y'all are real quiet and shy, at least check your answers with the other people to make sure y'all are getting the same thing. Okay, here we go. Breakout rooms coming. Three people per room. Is that okay with you all? 3 of you? I don't want to overdo it. One more thing before I put you in there. Everybody here today is going to get a quiz grade of 100. I'm not real happy with the participation today. We have 1, 2, 3, 4, 5, at least 5 people absent today. So yeah, I don't want that to become a habit here. So everyone gets credit for being here today. Who have I not called on? Because I need to make sure I call you. Let's see, Josiah, I've got both Josiahs. And I feel, Desiree, I haven't called you, right? I'm going to mark you down though. Okay. You should go into your rooms. Go to your room. Did I make the rooms? Yeah, I did. Okay. Okay, I have put the answers to both of these up here. The first one, I think the only tricky part here is when you square the 3x, make sure you square both the 3 and the x. Now that you can do, and the reason you can square each one is because there's multiplication between the 3 and the x. So when you square it, it becomes 9 and then x squared. Then you hit it with the 3 and it becomes 27x squared. Then the rest of it, I think, is pretty straightforward. Were there any questions on the first one? The second one is the trickiest one, and it is the most important one. All right. That is, what do you get when you plug in x plus h into the original function? So it has to go in here in parentheses, has to go here in parentheses. The easy part is distributing the 2. You get 2x and 2h. The hard part is you have to just expand the x plus h squared. So I did that over here on the side, and you have to FOIL. And when you FOIL, you'll have 2 terms in the middle that are like terms. You add those together to get 2 of them. And then don't forget that after you do that, you have to distribute a 3 through. So this final expression I have right here, I boxed it. Notice there's no like terms. Nothing can come together, right? In order to be like terms, you have to have the same variables raised to the exact same powers. So there's nothing I can do here to simplify this. So that is our answer. And I just want you all to know, again, this whole idea of plugging x plus h into a function is going to be very important for what we're about to do. Not today. Next class. Questions here?
Just real quick, sir. Does the order matter, like 3x squared plus 3h squared? Would that be right?
Yeah, good question. Juan's asking, does it matter what order these are in? I would say normally if you only have one variable, like just x's, then you want to go from the highest power down. That's the normal way we do it. But when you have multiple variables in your answer, you don't have to go from highest power down. You can just leave it the way it is. It's not wrong. And even if you did just have one variable like this right here, this answer right here, I could write that any order I want. It's not wrong. Okay. We just like to write things in what's called descending order. It's just a preferred way of writing it, but it's definitely doesn't make it wrong to switch it up. Okay. We are not going to have enough time to get into anything else. So for your homework tonight, make sure that you do all the stuff for solving equations. Go ahead and finish out that homework. And then I'll make any adjustments that I need to for the due date on functions. We're going to spend a lot of next class on this next section. So I'm not sure that we will finish this next time. Difference quotient is pretty, well, it's very important for calculus and takes a lot of time. So any questions on that? What's for homework? Good.
So just 1.4 is due next class.
Yep, just the 1.4. And I think that's on the online system. I think that's what it says. Hold on, let me just double check. Oh, I have 3-1 functions, don't I? So I'll change that due date. I'll change the due date for this one. Let me just do it right now. See if it'll let me. I have to log back in. I'll do it later. So just 1.4. Okay, everyone, just 1.4. Okay, now I still have you for another 9 minutes, so I thought I'd show you something. This will come up in calculus. This whole idea of taking x plus h and squaring it, right, requires that we FOIL things out, right, and do this multiplication. So I want to show you something that, like I said, might become useful at some point later in your life, your mathematical life. Let's say I take the expression x plus h, and I ask you to raise it to the 0 power. So do y'all know what anything raised to the 0 is?
0.
What's 4 to the 0?
One.
I see Gregory saying 1. Yes, this is 1. I'm going to write 1 up here. Now, I know it seems weird that I wrote the 1 way out here, but just bear with me here, okay? So x plus h to the 0 should be 1. Now, what would x plus h to the first power be? So anything raised to the first power should be itself, right? So that should just give me x plus h. So I'm going to write it like this. Now, x plus h squared is what we just did in the previous problem, isn't it? Okay, so that, I'm not going to go through the work, but that should give us x squared plus 2xh plus h squared. That's what you would get if you multiplied all that out and collected your like terms together. Now, does anybody know what x plus h cubed would be? Well, you would have to multiply this answer by x plus h again, right? One more time. And then FOIL it, or not FOIL, but expand it all out, and you'd get a bunch of stuff and you'd collect like terms, right? Okay, I'm going to tell you what it would become. It would become x cubed plus 3x squared h plus 3xh squared plus h cubed. You'll just have to take it on faith that that's what it would be, all right? X plus h to the 4th power would be x to the 4th plus 4x cubed h plus 6x squared h squared plus 4xh cubed plus h to the 4th. So that's x plus h times x plus h times x plus h times x plus h, multiplying all that out. I'm just so good at math, I can do it in my head, right? No, I'm kidding. I'm not doing it in my head. There's a pattern here. There's a pattern in this. I'm trying to see if you can get it. Next one, x plus h to the 5th. Any guess as to what the first term is going to be? Look at the pattern of the first terms.
X to the 5th power.
X to the 5th. Okay, that seems reasonable. That is correct. How about the last term? What does it look like the last term is going to be?
H to the 5th.
H to the 5th. Okay, that's correct. Now, all this crap in the middle, it's harder to see the pattern. Do y'all understand the 5th power? This 5th power on the h and the x are coming from this power here. See, in the previous one, it was 4 here, it was 4 here, 4 here, right? Okay, anybody see a pattern here?
The second one is going to be 5x to the 4th power h.
5x to the 4th power h. That's correct. How are you getting that?
Because we start out with 2xh, then we go 3x to the 2nd power h, 4x to the 3rd power h, because we're always 1 power down from the power that we're multiplying it all by.
Okay, so
And-
you're noticing that this power here, 3, is 1 less than that. The 2 is 1 less than that.
Yeah.
This, okay.
And the number
So-
in front is always the power we're multiplying by.
Okay, and then the number in front, 2, 3, 4, that matches this power.
Mhm.
I think I see that. I think I could agree with your logic on that, that this would be 5x to the 4th h. What about the next one, though? This one's a hard one. What would the next term be?
It would be 12x cubed, h cubed,
12x cubed what?
12x cubed, and then h cubed.
H cubed. Okay, that's a good guess. Let me help everyone try and see the pattern, okay? Because I've only got 3 minutes. Let's start out with the second line. The power on x here is 1, h here is 1. Okay. So in the first term, I have just x's. On the last term, just h's. As I move to the right, the power on the x goes down and the power on the h comes up. Watch, do it on the next line. Here's 2, right? What's the power on X on the next one? 1, right? And then on the next one, there is no X's. So the power on X's, look at all of these. The power on X's keep coming down. Cubed, squared, X, gone. Fourth, third, second, first, gone, right? So fifth, fourth, what? Talking about just the X's. Fifth, fourth, third, second, first, gone is what should happen, right? What about the powers on the H's? Do y'all see what's happening with the powers on the H's? H squared, H squared, H cubed, H squared, H cubed, H to the fourth. Those are coming up, aren't they? So as we move from left to right, the powers on X come down as the powers on H go up. So my next term should be, well, plus, let's not put a number in front. Let's wait on the number. This will be X to the third H squared, because the power on X came down, the power on H went up. The next one will be a number in front of that. I'm not sure what it is yet. And then it'll be X squared H cubed. And then it'll be plus, then some number, and it'll be X H to the fourth. You following? You'll see the pattern, yeah? Okay, let's talk about the numbers. I'm not sure who said that earlier. Was it Adam, or who was that got the 5? Was it Josiah?
That was me.
It was Adam. Okay,
Josiah
so
Reynolds.
Adam had got the 5, right? But you also thought this one was 12, yes? So I'm going to show you where the numbers come from, all right? And it goes back to over 2,000 years ago. This pattern was discovered by the Chinese. So what I want you to focus on in this are just the coefficients, just the numbers, okay? So when I talk about the numbers, I mean, here there's a 1. And then in front of this X, there's a 1, and there's a 1 in front of the H. So there's a 1 there and a 1 there. And then on the next row, it's a 1, and then a 2, and then a 1. So I've got 1, 2, 1. 1, 3, 3, 1. 1, 4, 6, 4, 1. Sorry, 1. Do y'all see that? Just, okay, now I'm going to write those down a different way. It's 1, 1, 2, 1. Sorry, no, I just messed up already. 1, 1, 1. 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. That's what these numbers would be. So let's see if we can find the pattern here. This next row that we have, where the hell's my cursor? This next row that we have a 1 here, right? So that should be a 1. We should have a 1 at the end for that H to the 5th. Okay, this next number right here, the next number that comes are these two added together. That's 5. This next number is these two added together, that's 10. The next one are these two added together, that's 10. And then these two added together, that's 5. And if you look back up at this thing, if you go pick any of these numbers, like pick the 3, where does that 3 come from? The 2 and the 1 above it being added. Where does that 6 come from? The 3 and the 3 being added. This is known as Pascal's triangle. I'm out of time. But I'll finish this out. So this is going to be 10, 10, 5, right? Like that. You can go if you need to, but watch, I'm going to just do one more. Knowing the pattern now, I can do this very quickly. Because I know, first of all, the powers on X are going to go down. X to the 6th, X to the 5th H, X to the 4th H squared, X cubed, H cubed, X squared, H to the 4th, then X, H to the 5th, and then the last one will be H to the 6th. So that's what I know happens with the powers going down and coming up. And then the numbers just come from the two ends are always 1. And then I take these two numbers, 1 and 5 together, give me 6. The 5 and 10 go together to give me 15. The 10 and 10 go together to give me 20. The 10 and 5 go together to give me 15. And the 5 and 1 go together to give me 6. And then I have a 1 at the end. So if you were to take x plus h times itself 6 times, you would get this. And you see, you could just keep doing this, like for as high as you want. Believe it or not, in calculus, that will become helpful if you know that, because then you can do things quickly. All right, we're out of time. You know what's for homework. We'll be back here on Wednesday, and hopefully I will have some information about whether or not we're going to meet face-to-face next week. Okay, everyone be safe. Have a good day. I'll hang out for a minute if you have a question.
All right, thank you.
Mhm.